Welcome to my video notes for 7.6 factoring quadratics and special cases. Now, a lot of what we're doing today is going to be a review from what we've done in the previous unit of quadratics last semester. So hopefully this isn't too hard because it should be review. Also, we did this in Algebra 1. So again, this is just something we're bringing back for the billionth time because it's not going away. All right, factoring quadratics in special cases. Today's learning target is that you can, it's missing a word here, you can factor quadratic equations by grouping. Today you're going to use A times C to find the factors that equal to B. You can group the first two terms together and the last two terms together. You can identify and factor out the greatest common factor, and then group and rewrite the factors of the polynomial. So a little warm up here, it says state the greatest common factor of the polynomial. The greatest common factor is going to be the largest number that divides from all three numbers. So looking at 4, 2, and 6, I know 4 is divisible by 2 and 2. I know 2 is divisible by 2 and 1. And I know 6 is divisible by 2 and 3. Now, what number do they all have in common? 2. So our greatest common factor is 2. So we are going to factor out the 2 from all three terms. What that means is we're pretty much going to divide all these by 2. And the 2 doesn't disappear. It goes in front of our new simplified polynomial. So here we have 4 divided by 2, which is 2x cubed. Then we have 2 divided by 2, which cancels or is 1, leaving us with x squared. And negative 6 divided by 2 is negative 3x. So we identified the greatest common factor. Oh, and I think we factored prematurely. That was step 2. So this can go down here. Don't worry about erasing it if you wrote it above, not a big deal. Okay, we factored the polynomial using greatest common factor. Now, second piece of the warm-up says, consider x squared times x minus 3 plus 2x times x minus 3 plus 3 times x minus 3. First question is, how many terms does it have? We remember that terms are separated by plus or minus signs. So the first term we have here is this one, then we have this one, and then we have this one. So altogether, this has 3 terms. What factor do they have in common? So looking at all of these terms here, what do they all have in common? I see that this has an x minus 3, so does this one, and so does this one. So the factor they have in common is x minus 3. Now it says factor using GCF. So what's their greatest common factor? It's that x minus 3. So if we were to divide out x minus 3 from all 3 terms, we would be left with x minus 3 times x squared, right here, plus 2x and plus 3. Okay. All right, and if I'm moving too fast for you, you can pause the video. Okay, factoring quadratics or trinomials can be factored using the grouping method. Grouping method means we're going to put some things into groups. All right, step 1, write the quadratic equation in standard form. Standard form we've been using with polynomials. We want the highest exponent first and go all the way down to, just go down in exponents, ending with our constant, which is just a number without x. Our next step will be to multiply a and c. Then we'll make a t-chart, and then we'll do some other stuff. So step 1, write the quadratic equation in standard form. Is this equation in standard form? Yes, it is. Step 2, multiply a times c and make a t-chart. So over here, I'm going to make a little t-chart. A times c goes at the top. And what goes at the bottom? B. So let's identify A, B, and C here. A is 2, B is 7, and C is -4. Oops, that's a 7. -4. Now, A times C, 2 times -4 is -8. And our B, 7, which is positive, goes at the bottom. All right, next step. Identify the pair of factors that equal B. So we want to list all numbers that multiply to 8. I know 1 and 8 and 2 and 4. Nothing else multiplies to 8. And we want to be more specific. Which of these pairs has, if one of these numbers were negative, they need to multiply to the 8, but add up to 7. So our special pair here is going to be -1 and +8. That's because -1 times 8 gets us that -7 or -8 on top. And -1 plus 8 gets us that +7 we wanted on the bottom. All right, so there's our special pair, -1 and -8. We are going to split the middle. Instead of 7x, we are going to say -1x and 8x. We can bring down the other terms, 2x squared and -4. Now that we have 4 terms, 1, 2, 3, 4, now that we have 4 terms, we can group them in pairs. First group and second group. Now from the first group, what is our greatest common factor? I see we have both terms have an x, so it looks like we can factor out 1x. From the second group, we need to take out the sign of the first term. This 8 is positive, so our factor is going to be positive. And what is the greatest common factor between 8 and 4? It is 4. And if you aren't sure, we could say 8, 2 and 4, and 1 and 8, right? Maybe I should have wrote it like a table. We could say 8 is 1 and 8 and 2 and 4, and 4 is 1 and 4 and 2 and 2. Now, what's the biggest number that they all have in common? 4. Okay, now this x plus 4 is going to be our first factor, x plus 4. And our second factor we get by dividing. We're going to say 8x divided by 4, and that gives us 2x. Then we say -4 divided by 4, that's -1. Now, these are the two factors. And we are done here. Let's take a look at number 2. This time, we only have 3x squared and 8x. Looks like our constant is sitting on the other side of the equal sign. We do need this to be in standard form, which means it goes from highest to lowest. And if there's an equal sign, there is nothing on the other side of the equal sign. So how can we get this to be highest to lowest with nothing on one side of the equal sign? We need to subtract 3 to the other side. Now our polynomial or quadratic is in standard form, and we can begin factoring. So let's go ahead and label A, B, and C. A is 3, B is -8, and C is -3. Now we start our t-chart. A times C goes at the top, which is 3 times -3. That gets us -9. B, -8, goes at the bottom. And now we want to list all factors of -9. We know 1 times 9, 3 times 3, And that's everything that multiplies to 9. Now, because 9 is negative, we need these numbers to multiply to a negative number, which means one of the numbers has to be negative. So if one of these numbers was negative, which one of them would add up to negative 8? If we have 1 minus 9, that would get us negative 8. And 1 times negative 9 would get us that negative 9 we're looking for here. So this is our pair that we're going to use to split the middle. So this negative 8 is now going to be x, positive x, and negative 9x. Then we can bring down the other two terms, 3x squared minus 3. Now that we have 4 terms, 1, 2, 3, 4, we can go ahead and group them into 2 pairs. One group and the second group. From our first group, what is the greatest common factor? What do they both have in common? They both have at least one x. So we can factor out an x. From the second group, we need to take out the first sign, which is negative this time. And what is the greatest common factor between 9 and negative 3? 3. Now we're ready to write our two factors. What we have beneath the groups, that becomes our first factor, x minus 3. The second group we get from dividing. We are going to say negative 9x divided by negative 3. That gives us 3x. Then we can say negative 3 divided by negative 3, which is positive 1. And these are the two factors of the original quadratic. Okay, let's take a look at example 3. Again, we need to start with getting our polynomial or quadratic into standard form, which means highest to lowest exponent with nothing on the other side of the equal sign. Now, one thing that I should note is that we never want the highest exponent to have a negative number in front of it when we are factoring. So something we are not going to do is subtract the 5x squared over, because then we get a negative 5x squared, and that can complicate things. So to make things a little bit easier for us, we are not going to move the 5x squared. We're going to move the 7x and the negative 2 to the other side. That leaves us with a positive 5x squared minus 7x plus 2 equals 0. All right. Now we have our quadratic. We can identify a, b, and c. A is 5, b is negative 7, and c is 2. Let's go ahead and start our t-chart. At the top, we have a times c. 5 times 2 is 10. And on the bottom, we put b, which is negative 7. Now we need to list all numbers that we know of that multiply to 10. I know 1 times 10, 2 times 5, and that's all that multiplies to 10. So let's go ahead and figure out. We need these two pairs to multiply to 10, which they do. And we also need them to add up to a negative 7 on the bottom. So which of these pairs, when added together, equals negative 7? 2 and 5. Now, because they're because they're multiplying to a positive 10, we do not need to change the sign. We only did that in example 2 because they needed to multiply to a negative, and we know that a positive and a negative multiply to a negative. Same thing in this example. We needed them to multiply to a negative number, and when you're multiplying numbers together, if one of them is negative and the other is positive, they will multiply to a positive number. Now here, they're multiplying to a positive number, So both numbers need to be positive. All right, back to it. We wrote all our factors of 10. We see that 2 plus 5 is, I see my error. Well, everything I said just a second ago is correct. But because we need them to add up to a -7, we also know that a negative number times a negative number, or I'm sorry, a negative number plus a negative number usually gets us another negative number. So we need both terms to be negative. And why does that work? Because negative times negative is a positive, which is what we're trying to get here. So if we have -2 and -5, they will add up to -7 and they will multiply to a positive 10. Okay, sorry, hopefully that wasn't too confusing there. We're going to split -7 to be -2x and -5x. We can bring down the +2 and the 5x squared. Now that we have 4 terms, we can group them. First group, second group. Okay, first group, what can we factor out? What do they have in common? Both terms have at least one x, so we are just going to factor out 1x. From the second group, we have to factor out whatever that first sign is. That 5 is negative, so we're factoring out a negative. Now between 5x and 2, what can we factor out? In situations like this, where 5 and 2 don't really have any numbers or factors in common, and they both don't have an x, we will just take out a 1. And in this case, a -1. Now we're ready to write our answer. Our first factor is what is below the groups, x minus 1. And our second factor is what we get when we divide the second group. So here we have 2. Oh, sorry, I should do it the first one first. -5x divided by -1, we're left with positive 5x. And 2 divided by -1 is -2. This is our factor. Our factors, there's 2 factors. Okay, now our next section says I can, again, missing a word here, I can factor quadratic equations with special cases. Let's take a look at there. I can identify when to use the sum of squares and difference of squares. I can take the square root of perfect squares. I can substitute the values into the formula correctly. So some special cases when factoring quadratics that you might see are these two right here called difference of squares and sum of squares, where the sum is when you add two squares. Remember the exponent of 2 is called the square. So sum of squares means when two perfect squares are being added together. And difference of squares is when two perfect squares are being subtracted. Oh, okay. So this is where we kind of need to know what our perfect squares are. A lot of the time you will be seeing, I guess we'll just write a few of them. Let's say 4 is 2 squared. Okay, let's try to stay still. 2, 3, 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. 36 is 6 squared. Oh, please stop moving. 49 is 7 squared. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. If anything, you might see one of these. Oh, well, I guess we kind of forgot the 1. 1 is also 1 squared. That's kind of one we forget about, but 1 times 1 is just 1. So that is also a perfect square. These are your perfect squares. Now, I will say, if you have not memorized these by now, you should probably get pretty comfortable with them. Otherwise, any problem like this, you might not recognize that these are difference or sum of squares. So, okay, let's take a look at this. Difference of squares and sum of squares. When anytime you recognize that we have difference of squares or sum of squares, you can you actually don't have to factor it. This is how you find its factors. You take the square root of a and b, and then you will get a and b and write them like this. So this is our steps. We start by identifying the perfect square. Then we take the square root of those squares, and then we substitute the values into the formula. So for example 1, it says x squared and 4. Now I know this is a perfect square because x times x is x squared. So if we were to square root x squared, we would get x. Now 4 is also a perfect square because we said 2 squared is 4. So the square root of 4 is 2. So what we need to do is think about it this way. We need to take the square root of both terms. That gives us x, and this gives us 2. Because it is subtraction, we're going to be using difference of squares. So we're going to say this is a and this is b. So we're going to say x minus 2 times x plus 2. There's your factored form. Let's take a look at example 2 below. Again, we have a perfect square. 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. And they're being subtracted, so we're going to be using difference of squares. Another way to set this up that might make more sense. Well, let's just keep doing it the same way. Square root, square root. What is the square root of 4? 2. And what's the square root of x squared? X. Now on the right, what is the square root of 25? It is 5. So now we can use these numbers to plug into the formula up here, where we say a minus b, so 2x minus 5, times a plus b, 2x plus 5. And bing, bop, bam, we're done with that problem. Okay. Let's try sum of squares. Notice how the only difference here is that the b is being multiplied to the imaginary number I. You actually don't have to do anything with I like we did in the past. We're just writing that that is a factor of this sum here. So we want to square root both terms. The square root of x squared is x, and the square root of 9 is 3. And now we plug it into our formula right here. X minus 3i and x plus 3i. That's it. Let's try example 2. We square root both terms. The square root of 16 is 4, and the square root of x squared is x. The square root of 81 is 9. And now we're ready to write our factors. 4x minus 9, I. 4x plus 9i. Okay, questions? All right, I want you to try these examples down here. You're going to identify whether you're going to use sum or difference of squares and then factor. Notice how some of these are not in standard form. We need them to be in standard form. How would we get number 2 here in standard form? we'd have to add the 36 to the other side. And now we see that this is sum of squares. Number 1's already in standard form. This is going to be difference of squares. 3, how do we get 3 into standard form? We said we don't want that x squared term to ever be negative, so that should be what we move over to the other side, leaving us with 121 x squared minus 25 equals 0. And now we can see it's minus, so this is going to be difference. And this one, number 4, is already in standard form, so we're going to say this is sum. And you know what? I'll just do these with you guys. Number 1, it is difference of squares, and that formula is above. I'll let you look at it. Here, what is the square root of x squared? It's x. And what's the square root of 1? 1. So we're going to say x minus 1, x plus 1. That's it. Let's take a look at number 3. Now that it's in standard form, we take the square root of both. The square root of 121, which we did write it up there, it's 11. The square root of x squared is x. And the square root of 25 is 5. Now writing our answer, 11x minus 5, 11x plus 5. And the last one here, again, we take the square root of both terms. The square root of 49 is 7. And the square root of x squared is x. The square root of 144 is 12. This is sum, so we need to use that sum formula up there. 7x minus 12i and 7x plus 12i. Now for number 2, again, square root both terms. The square root of 9 is 3, and the square root of x squared is x. What's the square root of 36? 6. Plugging it in, we get 3x minus 6i and 3x plus 6i. All right, that concludes our notes for today. Please let me know if you have any questions, and let's go ahead and use whatever time you have left to get started on the assignment.